have anything extra on cost that would help me?
I've got an electronic problem in cost, does the calculation of all the parts and as a joint of the house, everything too.
Okay. That's where I seem to struggle the most.
Yeah,
I know
both,
that.
I think both of us are,
One problem in the cost, but the cost though, for all of y'all, on that house calculation, it's a matter of slowing down, measure it correctly, find it on the chart correctly, and multiply it correctly, okay? It's a pretty elementary problem, but you gotta slow down and take your time and think it through. Does that make sense? If you get the good door rather than a great door, you mess it up. Or if you get the long item on that, if you get the indirect cost, there's several ways you can mess that problem up, okay?
writing down the wrong figures.
Yeah.
I'm gonna do that during the test. I don't wanna do that during the test. because then
Okay,
it'll be-
back at the ranch. Let's talk about this is the wrong ranch property, isn't it? I went to Slotsky's and I thought it was a pretty good deal. I kinda like Slotsky. My wife hates Slotsky's. We used to have one in Decatur. She swears she got sick both times she ate one. And she ate a salad once and pizza once, so she didn't eat the same family. And my daughter liked the ham and cheese original, plain and dry. Then I have to let somebody put it down.
You ever try that pot belly?
I don't eat any food that makes me feel bad, okay? I have a little nephew that's, or great nephew, excuse me. He's about 5 years old. His brother and daddy are not too much into Santa Claus, okay? They think they're lying to the kids. That's deception, so they don't play that. They don't have that situation at their house. So my brother's tried to give him a present for Christmas, and he always liked to play football, so my brother buys him a football and gives it to him and kind of presents it. Some fat guy in a red coat brought this to my house because you wasn't home. So he says, Uncle Mick! So anyway, so they're telling this story multiple times, of course. You get you one?
Yes.
And my niece is worried about me feeling bad about it. I said, my brother says, he works at the appraisal district. He's been called worse than that this week. That will be minor vocabulary problems for him this week, okay? You got one already, right?
Yes.
This is just kind of a recap of all those different formulas in 3.5 pages, you know, just so you kind of refresh yourself with you. Jump off the cliff on that one. Let's talk about mass a little bit. USPAP 2018-19 made changes to the standard, former standard 6. Now that is broke down into, standard 5 is mass appraisal development. Standard 6 is mass appraisal reporting. That used to be all under 6, now it's under 5 and 6. That's sure to be probably a question you're going to possibly see, okay? I'm just a guessing person. Or the question could say, which mass appraisal standard has to do with mass appraisal development? That's 5. Which standard has to do with mass appraisal reporting? It's 6. Or the question could say, which mass appraisal standard has to do with mass appraisal development and reporting? That's going to be standard 5 and standard 6, right? Economic principles and theory. Technically, mass appraisal considers all 3 approaches to statistical analysis, the universe of properties. The statistics are to appraise all those properties, allow a small group of appraisers to place a market value on a much larger group of properties with a certain degree of accuracy. These statistics provide quality control and procedures to ensure that we're doing some fair and equal or some uniform valuations, I think. Absolute value, that's when we do the calculation. That's a number without a sign, either plus or minus. So if we got a minus or a plus, we change them all just to a absolute value and add them up. We use that sum on the calculation of the mass appraisal central tendencies. Appraisal accuracy is a great term. It measures the measure of central tendency, tells us about how accurate we are. Appraisal to sale ratio, this is the relationship between the appraised value and the sales price, and that's always determined by the appraised value by the sales price. I think I told y'all earlier, if your appraised value is less than the sales price, your ratio is always going to have a 0.9, 0.8. If your appraised value is greater than the sales price, it'll be 1 point something, okay? So if you got it backwards, if you divide the sale by the appraised value, always think appraised value is less than the sales price, it'll be a decimal point in front of it rather than 1. It's a good way to kind of, everybody's divided those backwards at some point in their life, in a hurry or otherwise. Appraisal uniformity, appraising properties of a like type using the same methods and procedures so that no property or class of property is treated differently than others. Measure and dispersion, tell us about uniformity. An array is a list of numbers in order, either from high to low or low to high. That's a good term you're probably going to see. You're going to see a question about uniformity. You're going to have a question about the standards. The average absolute deviation is a total average. Absolute deviation is divided by the number of deviations. It's called the AAD, or the average absolute deviation. A baseline is a value produced by a benchmark property. We'll talk about benchmarks a little bit. A benchmark is a real or imaginary property that is represented by a larger class, a collection of central tendencies in itself. Bias is schedules consistently over or under appraise certain types of properties or features. Bias can be found through statistical testing because it is predictable in some types. Some of the bias types are common. Could be adjustment bias, age bias, location, quality, or size. Central tendency is the center of a typical value of probability distribution. Statistical midpoint of a set of numbers. In the array, we have our central tendency be the midpoint in that array of properties. We have classification system requirements. We always say all properties should fit into one class, but no property should fit into more than one class. Coefficient dispersion is the average percentage deviation from the median ratio. We're going to calculate some of those. The coefficient of variation is a ratio of standard deviation to the mean itself. Deviation is a great term. Bias is a great term. Deviation is the difference between a single ratio and the measure of central tendency. Dispersion is the degree to which data are distributed around the measure of central tendency. Distribution is the sample has proper distribution when it reflects the market under study. Error, the amount by which its observation differs from the expected value or an erroneous conclusion. You're going to have a question about mass appraisal definition at some point. It's the process of valuing the universe of properties as of a given date, using standard methods, employing common data, and allowing for statistical testing. Then we're going to have a mean. It's the sum of the observations divided by the number of observations, and the mean's nothing more than an average. We don't average, do we? We use the mean. That's kind of cruel, isn't it? We just don't average, we use the mean. Measures of central tendency. Market value can be the mean, the median, the mode, or the weighted mean. Measures of dispersion or appraisal uniformity is the COD, COB, PRD, range, percentile, quartile. Median, array data from low to high, and the observation is in the center is a median. If the set contains even number of observations, the two observations in the center are average. Remember that? If you got 5 numbers, it's going to be number 3. If you got 6, you're going to average 3 and 4, okay? Find a median. Median's a great term again. Mode, it's the observation that occurs most often. A set may contain more than one mode. You're going to be given a list of numbers to find a mean, a median, and a mode, probably for starters, okay? Then you're going to find a COD, You're gonna have an average absolute deviation, you're gonna do all those calculations multiple times. Model, fee schedule, it's a basic valuation model, equals market value, equals land value plus improvement value. And neighborhood, we've had this a couple times already. The geographic area that contains similar or complementary property uses that are subject to the same market conditions, are grouped by physical boundaries, use type, quality of construction. An observation of the great term is a single piece of data. Remember what an outlier was? The sales kind of on the low end or the high end, could be outliers. It could be, our situation now, if we're really, really low, it's probably next month's market, okay? It has a tendency to become what is like a 78%, 3 of them off, suddenly that's the new market, 60 to 90 days, we're just behind, okay? It's just, outliers seem to be moving to the middle all the time. Observations that fall well outside the normal range, either high or low. Percentile is values that divide a set of data that is rated in specific percentages and examining the relationship to the parts. Population is a group under study. The price-related differential is an indicator of appraisal progressivity or regressivity. And what you need to remember here is it's the mean divided by the weighted mean. The PRD is the mean divided by the weighted mean. That's how you get it. Not a real complicated formula. It's the mean divided by the weighted mean. But it does talk about progressivity and regressivity. We'll look at those terms here shortly. Progressivity, it may show you a group of numbers. And it says appraisal bias that higher value properties have greater appraisal to sell ratios than lower. Or lower priced properties are underappraised in relationship to higher priced properties. So the PRD is less than 1. So progressivity means lower priced properties are underappraised in relationship to higher priced properties. If that PRD is less than 1, it's progressivity. Quartile is dividing a set of data into, have been arrayed into ascending and into 4 equal parts, kind of break it into quarters and analyze it by those relationships. A random error is not predictable, may be an error in data entry or in measurement. That's here twice. Randomness, data has no recognizable pattern or regularity. A range may express from high to low, low to high. For ratios from 75 to 125, that range will be 75 to 125 or 125 to 75. That's just what they call a range, high to low, low to high. Ratio study is a study of a relationship between appraised values and market values to determine the level of appraisal. Here's regressivity. Talk about the PRD. If it's more than 1, bias that lower value properties have greater appraisal to sell ratios. So it's talking about regressivity, means higher priced properties are underappraised in relationship to lower priced properties. You could have a sample, they could give you the PRD, you may have to pick out if it's progressive or regressive. It's just a matter of memorizing those terms. Reliable, if data produces similar results under consistent conditions, is said to be reliable. A sample must have adequate size, distribution, and be random to be reliable, avoiding time adjustments. Sample size, you have a question about this, I'm sure, or have a sample. Sample size should contain at least 5% of the universe of properties under study and must be sufficient to represent the whole population. You could have 5%, but it might not represent the whole population too. You could have a neighborhood of varying values. You could have a 5% sample that came all out of one street rather than the whole neighborhood, so you got to kind of look at that for the sample size. Schedule is a table of unit values based on property characteristics data, maybe based on cost, market, or income data. Terms schedule and model are used interchangeably. Simple linear regression, statistical method that correlates size and value. SLR summarizes the relationship between the 2 variables. Let's draw this, but I don't think it covers it. I think I've read it a couple times. If you have a question about this, I'm afraid. It's one of those deals where we had a chart that said 80, 75, 70, 65 $80 per square foot. square foot houses, 1,400 square foot houses, and 1,500 square foot houses, it would show the fact that if these houses got bigger, they brought less money. That makes sense? So we show that the 1,200 square foot has to be $80 a square foot, where the 1,500 may be at 65. It's showing that the linear regression of those values based on size and price, okay? You may have a question about that too, though. We'll talk about that in a little bit too. But just putting it in a graph where it makes sense to say, hey, the smaller property will probably bring more per square foot than the larger property. The standard deviation, the measure that is used to quantify the amount of variation or dispersion in a set of data used in calculating a COB using parametric statistics, which we'll look at a little bit here too. Universe of properties defined by political boundaries that may be also called the population or group under study. And the weighted mean ratio, which we lose quite a bit in mass appraisal, is an aggregate ratio that gives you the weight to the individual prices and values. This can more accurately reflect their information in relationship to each other. To calculate the weighted mean, we add up all the appraised values and all the sales prices and just divide that total, okay? It's called the weighted mean. Some formulas in mass appraisal formulas. An absolute deviation, appraisal to sale ratio minus the measure of central tendency of the deviation. The appraisal to sale ratio, like I said, is the appraised value divided by the sales price. The average absolute deviation is the total absolute deviation divided by the number of observations. The sum of the deviation is divided by the number of deviations. A coefficient dispersion is the average absolute deviation divided by the measure of central tendency equals the COD. It can be converted to a percentage. And the coefficient of variation is the standard deviation divided by the measure of central tendency. Generally, we're talking about a mean. Location and neighborhood modifier, we'll take the number 1 divided by the mean. If the ratios are 80%, we'll take the 1 divided by 80%. We've got to apply a factor to our appraised values to raise those values up. Desired mean ratio is 1 divided by mean ratio. Price-related differential is the mean ratio divided by the weighted mean. Sample size population, it's 5% times the population. Schedule adjustment factor is, again, is 1 divided by the mean or median. Our desired ratio is always what? 100% divided by our actual ratio. And the weighted mean ratio is the total sample of appraised values divided by the total sample of sales prices. Lots of terms, there's lots of questions that can come from those terms too, okay? I've encouraged you to memorize or study most of those terms carefully. I've got some highlighted, some not highlighted, but let's go back to the highlights, okay? On page 145, I've got appraisal accuracy, appraisal to sale ratio, uniformity, array, and benchmark. 146, I got bias, deviation, mass appraisal, mean, and then the last 4. 147, that neighborhood, observation, outlier, PRD, progressivity, range, and regressivity. And on 148, I've only got weighted mean ratio highlighted, and on 149, I got all the formulas highlighted. Let's talk about our 4 basic steps in mass appraisal. And the questions, you have a question is what is the first step in mass appraisal? What are you going to do? Analyze your market. How are you going to do that, Jimmy? You're going to run a ratio study, aren't you? Number 2, you're going to develop a property classification system for land and improvements. You're going to build schedules. And you're going to test schedules, aren't you? The question could say, which of the following is not one of the basic steps in mass appraisal? You can throw something else in there and take one of them out. So you could have an is not question here, possibly. We're looking at planning and reappraisal. Again, our first step is to what? Kind of assess where we're at, it's our first step. Probably gonna do ratio studies, see where our values are at. Set reappraisal goals, assess available resources and determine the needs, reevaluate goals and adjust as necessary, and develop a work plan. Conducting a ratio study, determine the manner in which the sales will be categorized, determine the sales to include, select the study sample, compare appraised values with actual sales prices, calculate the ratio for each category, then test the ratios for reliability. How we use ratio studies, we test the present appraisal system and our values. We also use it to test schedules on a pilot basis before using the schedules. And we actually test the master appraisal system to evaluate the system and identify areas of strength and weaknesses. We use it also to test for equalization, don't we? Let's talk about the measures of central tendency. Here's a term you're probably going to see. Mean. That's a term I can almost promise you're going to see a definition of a mean. It's add them all together and then divide by the number of observations. So we got all our ratios here from 75 to 110. That totals up to 9.57. And we're going to divide that by the number of ratios of 10 to get a 96% mean, or 0.96% mean. Means real simple, add them up, divide by the number of observations. The median is not a real pain either, but what you try to do is find the one in the middle. In the observation here we're talking about, it shows us that the one in the middle happens to be two of them in the middle. So we're going to take these 98, 99 together and then average those two to get the median. So in this case, we rounded it. I'll take that one on the chin. We added the 98, 99 together, divided by 2, rounded the nearest whole number of 99 for the median. Median's pretty straightforward too. If we had 9 numbers, we'd have picked the middle one. We got 10, we got to average the 2 in the middle. Median is always going to be in the middle, like the median of the highway. The mode is not the, your children were small, they said, I got the mode. This is different. It's the one that observation that occurs the most often. All these definitions, mean, median, mode, are great definitions to memorize. We're going to take the one that occurs the most often. Our sample shows 1.01 occurring 3 different times. Now then we're getting into a little more number crunching. Finding a measure of central tendency called the weighted mean. If you remember this from your math class, all we're going to do is add up the total amount of the sales prices, total amount of the appraised values, and then we're going to divide, aren't we? So our total appraised values are $3,054,134. Our sales prices are $3,393,793. So before we even calculate this, let's look and see. Our appraised values are what? They're less than the sales price. So our weighted mean is going to be what? Point something. It's not going to be a 1 point something. So I'm going to tell you what's happened here, just for grins. Normally, we've been looking at this stuff today, it's had the appraised value here, the sales price there. We'll flip-flop in this particular instance, okay? So that tells us our appraised value's got to be divided by our sales prices because we are lower, until we're lower. So our median, weighted mean, is 0.90. That's this 3,054,000 divided by this 3,393,000. We're setting at about a 90% weighted mean. And we know it's too low, isn't it? Our boss expects us to do better, don't they? Measure dispersion or measure of uniformity. We try to use the same methods, procedures, no proper class, read it differently. Measures of dispersion tells us about uniformity. Now here's a range. It's a simple term. It's either 75 to 110 or 110 to 75. That's our range of values in this case. So it's just a simple high to low, low to high. Now, the next question here is a percentile. Dispersion percentile is a little more complicated. Don't hear a lot about it, so we'll kind of look through it here. The ratio is in the 10% range here. We've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 1 through 10, this is the lower 10%, this is the 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and 100%. So 50% of our ratios are basically between what? 75 and 98. 60% of them are between 30 and 99. 80% are between 101. Same on 90. And 100 goes to 110. Quartiles, this is breaking it into quarters, taking the same thing before. We have this into percentiles. This is in quarters. We got quarter 1, quarter 3. We got quarter 2 in here somewhere too, okay? Then we got a fourth quarter. So the lower quarter is 75 to 92. Second quarter is 92 to 99. Third quarter is 99 to 101. And the last quarter runs from 101 to 1. Sometimes we'll use this in dispersing these numbers, okay? Dividing a set of data into 4 quarters, sometimes we can analyze those a little more closely that way. Now we get into the COD, the coefficient dispersion. This is called the average percentage deviation from the median, another term you might want to hang on to. It talks about mass appraisers use the COD as a method of measuring. Because it is the best method for the non-parametric statistics. This method used by the state comptroller in the value study. This is where it comes home and roost. The fact is, it's coming home and roosting for us. So here's our ratios. We got COD calculation of appraisal cell ratio of 75, 88, 92, 92, 98, 99, 101, 101, 101, 110. So what's the first thing we got to find? How are we going to find our median? What two's in the middle?
5 and 6.
Huh?
5 and 6.
Our median's right here, isn't it? 98, 99, so we got 4 below, 4 above, we got 2 in the middle, 98, 99. So we're going to add those together, divide by 2, and we're going to round it to 99, aren't we? So our 99 is going to be our median. It's going to be falling right in between these two numbers, isn't it? 99 is our median. So now then we're going to calculate our deviation. So we're going to take our median, or measure of central tendency, and we're going to subtract. So this 75 is 24 deviation points, 11 deviation points, 7, 7, 1, no deviation, 2, 2, 2, and 11. That's the deviations. So we're working on the COD. Everybody good so far? Is yours worked out? Is y'all's worked?
Uh-huh.
Okay, cool. So it is working, that's good. So now then, we have our deviations. We're going to add our deviations up, and that gives a total of what? 0.67. And we're going to divide that by the number of deviations, which was 10. So our average absolute deviation is 0.067. And we divide it by our measure of central tendency, in this case, the 0.99. And that gives us a COD of 0.0677, or 6.77%. Y'all remember this from your class? The time I got to this class, I've been doing this about maybe 2 years. This kind of helped bring everything together for me. All those statistics we talked about with the value study made sense now. This is how we do it. This is why we do it, how we do it, how we get there. So this give me the COD and let me know. We was doing it on a Lotus 1, 2, 3 spreadsheet. You know, put the numbers in, doing the magnitude deviations, and do it that way, which is kind of archaic, so to speak. Is everybody good with this COD? Could you work one if we have one later? We're gonna have something later, I promise you, okay? So we gotta work one, okay? Let's move on to the COV. The coefficient of variation. It's a ratio of standard deviation to the mean, used mostly in parametric statistics, although it's used in mass appraisal when the data has been stratified or otherwise modified to mimic parametric data. You do this, not to be to know how to calculate COV for this test, but it would be a great tool for your job. That's weird. There we go. Okay, here we go. PRD. The PRD is an indicator of appraisal progressivity or regressivity. We talked those terms a while ago, you need to remember. Which describes appraisal bias. The following example indicates appraisal regressivity, or that higher priced properties are underappraised in relationship to the lower priced properties. Here's the PRD. We said earlier, just memorize the formula. Mean divided by weighted mean. I look right over, she say, Kara say, I'm mean. And she make a little face, you know. That's how I remember it's mean divided by the weighted mean, okay? So we got all of our ratios. And we got our mean ratio of 96. We got our weighted mean of 90. We're going to divide that 96 by 90, you got 107. So that's telling us that we're overappraising what? The lower priced properties are overappraised, and the higher priced properties are underappraised. In other words, we're regressive. Our ratios are lower on our higher priced properties than on our lower priced properties. What's in our following example? Regressivity, or the higher priced properties are underappraised compared to lower priced properties. Is y'all's finished in y'all's book?
It doesn't have the answer. It doesn't say regressive anywhere. I don't see it.
It's not showing you this answer right here. 96 divided by 90.
No.
Write that in then, okay? I gotta know you're not finished. So divide the 96 by the 90. That means we're regressive. The PRD above 1 means we're regressive. That means our higher priced properties are underpriced. Is they done? Let's talk about some basic steps here in building a schedule. We're going to analyze our market to determine what features for land and improvements enhance or detract from value in our area. We're going to develop a property classification system that defines benchmark properties for each land and improvement category. We're going to build improvement schedules, and we're going to test those schedules, a ratio study. We said the median is a measure of central tendency. Here's a slide here, a problem. Here's an added slide. Average absolute deviation, or the mean deviation, is the total absolute deviation divided by the number of observations. The coefficient dispersion is the average absolute deviation divided by the measure of central tendency, mean or median. Adjustment factor is the desired ratio divided by an actual ratio. And location modifier is used to make schedule adjustment is desired mean ratio divided by the actual mean ratio. Here we're testing here's a sample question here. Let's talk about in testing building schedules for 70,000 single-family residences with a ratio study. The appraiser should try to get the sample size of how many properties? About 3,500 should be. That's 5% of the 70,000. Okay, they're on page 159. You have a question, and I want you to spend some time working that question. I want you to find the mean, the median, the mode, the weighted mean, the location adjustment, the PRD, and the COD. And you'll be brain dead by then, okay?